Exercise 10.5, question number 2. A chord of a circle is equal to the radius of the circle. Find the angle subtended by the chord at a point on the minor arc and also at a point on the major arc. What is given is a chord of length equal to the radius. So, I have taken AB as a chord of the length equal to the radius, and this is the center of the circle I have joined here. So, we got a equilateral triangle here. What we have to find is, you have to find the angle subtended by the chord at a point on the minor arc and also at a point on the major arc. See, this is a chord AB, which is the major arc, this is the major arc. So, this is the angle made by this chord at the major arc. AB is the chord and this is the major arc, and this is the angle made by this chord AB at the major arc. Same way, ADB is the minor arc, and this is the angle made by this chord at the minor arc. This is the angle made by this AB at the minor arc. So, what you have to find actually is, we have to find this angle and this angle. So, what is given here is AB is equal to the radius. So, I have drawn an equilateral triangle here. So, what about the angle AOB? All the angles are equal to 60 degree. So, angle AOB is equal to 60 degree. Angle AOB is equal to 60 degree. So, we got this as 60. If this is 60, what about this angle? If this is 60, what about the angle ACB? Is half of 60. Why? This is the arc made by, this is the arc which makes these two angles with the center and at any point on the circle. So, if angle AOB is 60, we can say angle ACB is equal to 60 divided by 2, which is equal to 30 degree. What's the reason? Angle made by an arc at the center is double the angle made by it at any other point on the remaining part of the circle. Actually, this is the angle made by this chord at the major arc. Then we have to find the minor arc. So, this is the minor arc, and this is the angle made by ADB, is the angle made by this chord AB at the minor arc. So, ADB is equal to angle ADB is equal to, how can you find angle ADB? What about this ACBD? What about this quadrilateral? It is a cyclic quadrilateral. So, what about sum of opposite angles? Sum of opposite angles 180 degree. We got this as 30. So, how can you find this? 180 minus 30. Angle ADB is equal to 180 minus 30, which is equal to 150 degree. The reason is ACBD is cyclic. So, this is the angle made by this chord at the major arc. This is the angle made by the chord on the major arc, and this is on the minor arc. Next, third question. In figure, angle PQR is given as 100, where PQ and R are points on the circle with center O. We have to find angle OPR. Say angle PQR is given as 100. So, this is the angle made by this arc. This is actually the major arc. So, This is the angle made by the major arc PR on the point Q on a circle, or at the point Q on a circle. So PR is a major arc which makes angle PQR on the circle or at a point Q on the circle. So what about this angle? What about this angle? What is the connection between these two angles? So we have already learned that this is half, or this is the double of this. What is the name of this angle? This is actually reflex of angle POR. Reflex of angle POR is equal to 2 times PQR when the arc is major. We have proved that. So what we can say is reflex angle POR is equal to 2 times 100, which is equal to 200. What is the reason? Angle made by an arc at the center is double. Same reason. Angle made by an arc at the center is double the angle made by it. So reflex of angle POR is equal to 200. What about angle POR? What about angle POR? What is the connection between these two angles? It is angle at a point. So it is 360 degree. So angle POR is equal to 360 minus 200. Reason? Angle at a point. At a point is 360 degree. So that is equal to 160 degree. So what we got is this angle is equal to 160 degree. What we need actually? We need these two angles. So what about OP and OR? OP and OR are radii. So they are equal. So OP is equal to OR radii. So what we can say? Angle OPR is equal to angle ORP is equal to x. Why these two are equal? Angles opposite to equal sides. Angles opposite to equal sides. Then what you have to use is angle sum property. 160 plus x is equal to 180 degree using angle sum property of a triangle. We are using angle sum property in triangle PRO. So what we got is 160 plus 2x is equal to 180 degree. So 2x is equal to 180 minus 160. So 2x is equal to 20. So what about x? 20 by 2, which is equal to 10 degree. Therefore, angle OPR is equal to 10 degree. This is the answer. So what we have done? Here what is given is angle POR is equal to 100. If angle POR is equal to 100, this angle is equal to 2 times 100. That means reflex of angle POR is equal to 200. So after getting this, we got this as 160 using angle at a point, and what you have done next is OP is equal to OR using radii. So if these two are equal, we can say the angle opposite to these two sides are also equal. So we have taken it as x. Then we have used the angle sum property of the triangle and we got x as 10. So angle OPR is equal to 10 degree. Next question. In figure, angle ABC is equal to 69 degree and ACB is equal to 31 degree. Find angle BDC. What is given? Given angle ABC is equal to 69 degree and angle ACB is equal to 31 degree, what you have to find? To find angle BDC. Angle BDC. This is what you have to find. So here what we are using first is angle sum property of a triangle itself. Here consider this triangle ABC in which two angles are given. So you can find the third angle using angle sum property. So angle BAC is equal to 180 minus 69 plus 31 using angle sum property of a triangle. So we can write as 180 minus 100, which is equal to 80 degree. So we got angle A as 80. What is the connection between angle A and angle D? What's the connection? Angle A means angle BAC and next one angle BDC ending with the same point. So what we can say? They are in the same segment. So they are equal. Angle BDC is also equal to 80 degree using angles in the same segment. This is the answer. So here what we have applied is angle sum property. Using that we got angle BAC, but angle BAC and BDC are equal because they lie on the same segment. Then next question, fifth question. In figure ABCD are 4 points on a circle. AC and BD intersect at a point E. Angle BEC is given as 130 degree and angle ECD is equal to 20 degree. Find angle BAC. So given angle BEC is equal to 130 degree and angle ACD is equal to 20 degree. To find angle, what do you have to find? Angle BAC. To find angle BAC. Here actually we need to get one triangle to find the last angle. So we have to get this triangle EDC first. So we will get this angle. After getting that D, we can find A. So what we are using here is, see, we got already one angle is here. So we can find this. How? Using linear pair property. So angle DEC is equal to 180 minus 130, which is equal to 50 degree using linear pair axiom. So if this is 50, how can you find this? Using angle sum property. So angle BDC is equal to 180 minus 50 plus 20. So which is equal to 180 minus 70, which is equal to 110. You have to write the reason here, angle sum property. So we got angle BDC as 110. What is the connection between BDC and BAC? Ending with the same. So what we can say? These two are equal using angles in the same segment. So angle BAC is also equal to 110 degree using angles in the same segment. This is the answer. This is what we need. Angle BAC. What we have applied first? We have applied linear pair axiom first. After that, we have applied angle sum property in a triangle. Then we got the angle BDC, and angle BDC and angle BAC are angles in the same segment, so they are equal.